Alright. Sine and inverse sine is next to each other. So you can apply the shortcut here. Look at this inner value. 1/2. For arc sine, it has to live between these two values. Is 1/2 in that range? Yes. It's got a bracket around it, doesn't it? So what will be my answer there? 1/2. Do you see that? You said, Mr. Chester, I'm just not good at the shortcut, so can I do it the long way? Yes, let me show you how. Because in a minute, we got to do every one of these the long way because we're going to go into complex problems here. Alright, let's say you don't like the shortcut. We're going to work from inside out. The arc sine of 1/2. Arc sine comes out of quad 1 and 4. This will be quad 1. Your y value is 1/2. That's the pi over 6 family. The pi over 6 family, remember, that's in quad 1 is pi over 6. Okay? This is a regular problem now, isn't it? Sine pi over 6. That's the y value. So your answer is 1/2. Do you see how that works back out? So you can do it either way. It's fine with me, okay? I'm not going to sit there. As long as you get the right answer, that's impressive. Now, number 9. Why can you not do the shortcut here? It does not fall between 0 and pi. Very good, Holly. 5 pi over 2. How many times does 2 go into 5? 2 and 1/2 doesn't. So you have to work from inside out. Cosine of 5 pi over 2, we already said it's 2 and 1/2. So I'm back at what degree? 90 degrees. What's the cosine of 90 degrees? 0, isn't it? Okay. So I evaluate this as 0. Now I got to find arc cosine of 0. I got to think between 0 and pi. Where's my x value 0? That's your answer. Now, do you realize you can even think of the shortcut here because those are two different trig functions, aren't they? So you got to work from inside out. So tangent of pi over 4, that's a regular problem. What's tangent of pi over 4? 1. Okay, so 1. Now, I got the inverse of cosine of 1. It's got to be between 0 and pi. Where's your x value equal to 1 at? 0, isn't it? Because pi is -1, isn't it? So the answer is 0. I was going to use microphone today, but I think I'm loud enough for that. You agree, Mason? That'll give you a headache with it. And just ruin your day. We don't want you to ever be in a bad mood. The world's not ready for when you're in a bad mood.
I'm in a good mood today.
I know, I'm just saying. I'm just talking about other times. So,
Alright. I'm going to remember that.
You've been a great week. Like you said ago, you've been happy 2 days in a row. I'm proud of you. All right, number 11. Let's go for 3 days. We're not going to be perfect. I'm not saying 4 out of 4. We're going to do 3 out of 4. Okay? That would make my day. And then next week 5 out of 5. Whew. All right. Cosine of pi over 3. Regular old cosine of pi over 3. What's cosine of pi over 3? 1/2. Arc sine of 1/2. So we have to think that's coming out of quad 1 or quad 4. The y value is positive, so what quad are we dealing with? 1. Which family, pi over 6 or pi over 3, has a y value of 1/2? Pi over 6. What family member of pi over 6 is in quad 1? Very good, that's your answer. Now y'all see why we spend 3 days on this? It starts clicking by about day 3. All right. Number 12. Work from inside out. Sine of 0. Now, that's not arc sine. That's just sine of 0. They're talking about the ordered pair 1, 0. Do you understand that? What is sine of 0? 0. So now we're going to go arc tan, or inverse tan, whichever way you want to say it, of 0. That falls between quad 1 and quad 4. Remember, in this case, y divided by x will give you 0. Am I talking about pi over 2, 0, or negative pi over 2? 0. So your answer is 0. Are there any questions on the front page? This will disappear by Friday. I promise. Like, this is the last day you see this. This has been an anchor to help you set sail. It sinks to the ocean this afternoon. All right. Number 13. Cosine of pi over 2. What's cosine of pi over 2? Thank you, Derek. Cosine of, we got to know that. Cosine of pi over 2, what is it?
0.
What is it?
0.
Thank you. Be confident. 0. Now I'm going to do arctan of 0. I feel like we just did that one. What is it? 0, yes. Inverse cosine of negative square root of 2 over 2. So we got to look at it. Cosine comes from quad 1 or quad 2. Cosine refers to your x or y? X. So would x be negative in quad 1 or quad 2? Quad 2. What family are we dealing with? Pi over. What pi over 4 family member is in quad 2? 3 pi over 4. So I'm going to put tangent of 3 pi over 4. Now, 3 pi over 4 falls in quad what? 2. What will be your answer here? 1 or negative 1? Negative 1. Because remember, you got different signs in quad 2. Number 15. Sine of pi over 6. What's sine of pi over 6? 1/2. Inverse cosine of 1/2. We got to think quad 1 or quad 2? 1, okay? Which family? Pi over 6 or pi over 3? Which family member of pi over 3 is in quad 1? There's your answer. Are there any questions up to 15? Because we're about to start some that's kind of different. These are easy, so don't freak out. We're only going to do about 3 more. We're not doing all 6 of these. Okay. Do you notice you start seeing some weird values? We have studied anything with negative 3/4, 5/12, or 4/5 on there. Do y'all agree? Okay, so I'm going to teach you another way how to do this. You have to draw a triangle. You have to incorporate some of our right triangle tree. Remember opposite over hypotenuse and all that? Alright, so what you do, guys, is you look inside and you set it up as tangent of u equals, don't let this get you confused, just watch me. Instead of putting arctan, let this be tan u equals negative 3 over 4. Don't let the symbol get you all confused. I'm going to explain that to in a minute, okay? Now, arctan of negative 3/4. Think of this arctan. That comes out of quad 1 and quad 4, don't it? If your tangent is negative, where am I going to draw my triangle, in quad 1 or quad 4? 4. Just draw you a triangle somehow. Because that tangent was negative, arctan can only live in quad 1 or quad 4. I'm not going to be drawing no triangles for arctan in second and third. It's either 1 and 4. You can put this little u right here. You're doing something called u substitution. That's fine. So you just put it on that table right there. So you're letting tan u equal negative 3/4. In the right triangle world, what's the definition of tangent? Opposite over what? Adjacent. Opposite over adjacent. Tangent. So what's opposite of u? Right here, isn't it? Because that's the hypotenuse down here, isn't it? What is your adjacent? Okay. So you see how I set that up. And you can also think of this. Is it tangent y divided by x? Isn't this dealing with your y-axis and that dealing with your x-axis? So you can put it like that. Okay. Now, what theorem can you use to find the Pythagorean theorem? And your hypotenuse is always positive. So what's negative 3 squared plus 4 squared equal? 25. What's the square root of 25? Okay.
Why can't we use that for all of them?
You talking about the other ones? It doesn't work like that for them all the time.
That's so sad.
I know. Some people like these better than other ones. Now, all you got left is cosine. What's the definition of cosine?
In terms of triangle?
Yes, in terms of triangle, cosine. Adjacent over. What's adjacent to you?
4.
What's your hypotenuse? That's your answer. Yes.
So, and I probably just didn't hear it.
Mhm.
So when do you use this? Like, cause
You only use this when you have weird values like this.
When they look not correct.
so like if it's not something you can find on the
Unit circle, yes. And something that you can't do the shortcut with.
It'd have to be a fraction though, right?
Yes. Well, if it wasn't, then you just put it over 1 and make it a fraction. Alright, shh. Number 17. I have a weird fraction, 5 over 12. Arctan. Arctan lives in quadrants 1 and 4. This is a positive tangent. So where would I draw my triangle? In quadrant 1 or quadrant 4? 1. Tangent is defined as what in right triangle trig? Opposite over adjacent. So 5 would go here, 12 would go here. How will I find my hypotenuse? 12 squared is 144 plus 5 squared is 25. That gives me 169. Square root of 169 is 13. If you have to work that out, feel free to. Now I want the sine of that. What is the definition of sine? So what's opposite of you? What's your hypotenuse? That's your answer. You can put u or theta, it doesn't matter. We're going to do 18 and 19. Do we know a 4/5 on the unit circle? No. Arc cosine of 4/5. Arc cosine comes out of quad 1 and quad 2. Cosine is your x value. Your x is positive here. So where would I draw this, in quad 1 or quad 2? 1. Cosine is defined in the right triangle trig as what? Everybody. Adjacent over what? Okay, what is sine? We got to clear this up. What's the cosine? Adjacent over hypotenuse. What is sine? Tangent. You cannot forget that, okay? Now, so adjacent is here, a theta. My hypotenuse is 5. So I'm finding a missing leg. So you got a squared plus 4 squared equals 5 squared. So what would this be over here? 3. I want the sine. What is opposite of theta? 3. What's my hypotenuse? That's your answer. Now I want you to pay close attention, 19, and I'm going to let you work on homework. Arc cosine of negative 3/5. Your x value is negative. Would I graph this in quad 1 or quad 2? 2. So I'm going to draw a triangle quad 2. This is where you need to pay attention right now. I told you your hypotenuse is never negative, isn't it? So where would this negative go? Will it go with the 3 or the 5? The 3. Do you understand that? Okay. Now, cosine is adjacent. So this is negative 3 and this is 5. Now, my question to you is this. What sign would this have? It is in quad 2. And this is associated with the y because you're going up, isn't it? So would this be a positive value or a negative value here? Positive. Do you understand why? Okay, so if I do Pythagorean theorem, this gives me 4. I want the sine of that. Opposite of theta is 4 over the hypotenuse is 5, 4/5. Okay? You only do this when you have weird values, okay? Alright. And also, think of this. Hey, I need to include this on it for a minute. Let me include this for a minute. Doesn't negative 3, 4... No, I'm not going to do that. Never mind. Alright. Before we start our homework, let's review our identities over here for just a second. Reciprocal. What's the reciprocal of sine theta? 1 over cosecant. What's the reciprocal of cosine?
1 over secant.
1 over secant. Tangent.
1 over cotangent.
Cosecant.
1 over sine.
Secant.
1 over cosine.
And I understand you're saying 1 over cosine sine, but on test put 1 over cosine theta, okay? You don't have to say theta right now, but just know to put that. Okay, cotangents, 1 over
Tangent.
Okay, now go to quotient identities. Remember, this involves division. Tangent. Think of tangent as y divided by x, but what's another way of writing that? Sine over
Cosine.
cotangent will be?
Cosine over sine.
Very good. Pythagorean identities, what's the easiest one?
Sine squared plus cosine squared equals 1.
Very good. I'm going to teach you a trick on these last two. Notice they both, now you can put, now it doesn't matter if one comes first or tangent, it does not matter if one or cotangent comes, because isn't addition commutative? But just remember, the beginning of both of them involve tangent and cotangent, okay? And over here involves the reciprocal of sine and cosine. You see how the c's go together? 1 plus cotangent squared is equal to cosecant squared. 1 plus tangent is equal to secant. That's how I remember that, okay? So both of these start with tangent and cotangent. You just got to get the last part right, okay? So cotangent plus 1, cotangent squared plus 1 equals what? Cosecant. Tangent squared plus 1 equals? You got to remember that. Okay, work on your homework. I need a hand signal. How do you feel after 3 days on inverse trig? I need a hand signal. Everybody. Okay, we're going to do some more. I'm going to give you a check for tomorrow. We're going to keep working on this tomorrow, okay? We're going to keep reviewing. This will be day 4 tomorrow.
See my test for this week?
See your what?
Test.
Your quiz?
I have the test.
Which test?
On graphic
You're getting those tomorrow.
Okay.
I'm handing your test back tomorrow as part of our review.
So this is a cumulative test?
Yes. It's going to have 2 sine and cosine graphs. The rest of them what we've been doing in the inverse trig. Yes.
Clarifying, so like on this one, since they're the same and that falls within the range, they can cancel and it equals negative 5 or 6. Right?
Correct.
Okay.
Yes. Yes. Yep. Now that is outside of pi over 2, isn't it? So you're going to work from inside out. Yes.
Yep. And that one we get confused on because that's what I was trying to.
That right there, and you can just triangle. Yep. You have to do triangle on that one, that one, that one, and that one.
Yeah, because it made sense in my head that we undefined with the cosine and then undefined tangent undefined pi over 2.
Yes.
But you substitution's a thing. So.
Yeah. Oh, and Jack, you're right. You said it had to be a fraction. Yes, I'm not going to get. To draw the triangle. To draw the triangle, I'm going to have to present you a fraction. It's not going to be like you would not do something like that for a triangle. Okay, you wouldn't put that 125 over 1. Okay.
No, nothing.
You remember a while ago you asked me, would it have to be a fraction?
Yeah, cosine.
Okay. So that you would not draw a fraction for that. I mean, not a fraction, a triangle. It's like on these that's already presented to you in a fraction. Does that make sense? Colby, you good? Okay. You good, Harrison? Okay.
So are all the triangles going to be Pythagorean?
Not necessarily. No. You might have some radicals on them. Yeah, there was a question Harrison said, are they all going to come out nice and easy like Pythagorean theorem, like Pythagorean triples? No, you might have some square root. Just remember, if you get a square root in the denominator, what you got to do? Rationalize. Yes, you can work with each other on this. I'm coming, Mason. Let me just get ready for next class. Oh, let me stop my video.